All right, so we have our first free response question where we have a car accelerating from rest over a distance of 200 meters. So that means its initial speed is 0, its final speed is 0. X is 200 and x naught is going to be 0. So let's just solve some things. So it says we want to know the time it takes the car to get from rest to 40 meters per second and the acceleration of the car. So let's first get the acceleration. We've got v squared is v naught squared plus 2 times a times x minus x naught. Awesome. And with this in mind, we can solve v squared is 1600 because I square 40. 0 squared plus 2 times unknown a times 200 minus 0. So it looks like I'm actually getting an acceleration of 4 meters per second squared when I solve. And let's use v equals at plus v naught to get the time it takes. That's going to be 40 equals 4 times t plus 0. And so I'm getting a time of 10 seconds. Oops. Time is 10 seconds. Now continuing on this, we want to know the total force on the car, so let's just do a free body diagram quickly. So we've got the pushing force of the motor, friction, we've got the normal force, and we've got the weight. Now we know that the normal balances the weight since the car doesn't fly up into the air or crash into the earth, and we know the pushing force has a tug of war with the friction, and the effect is the car accelerates. Now the total force on the car would be this minus friction, but we can't seem to get that, but we do have the mass and we do have the acceleration, so why don't we just plug in with the total, get the total force by plugging in M and A. So that's going to be 500 times 4, and that's going to give me 2,000 newtons of total force. Now it says the pushing force is 2,500, so we want to figure out the coefficient mu of friction. And you know what? So I should say the coefficient of friction acting on the car. So let's be clear. We got normal, we got weight, we got pushing force, we've got friction, which is the same free body diagram from above. I'm just redrawing it. So we know that Fp minus F equals Ma, and let's plug in what we have. So I know that 2,500 is the pushing force, the friction force is unknown, and we got Ma in the previous is 2,000. So I'm getting a friction force of 500 newtons. Now, I want to get the coefficient, so that friction is mu times normal force. Well, we know normal equals the weight, and since the mass is 500, that means the weight is 5,000 newtons. So I'm going to get 500 equals mu times 5,000, and I'm getting a mu equal to 0.1. Now, we want to plot the position, velocity, and acceleration graphs, assuming the car is moving forwards. Well, the position graph, that's going to be a parabola moving forwards. The velocity graph looks like this, and the acceleration graph looks like a flat line here. So this is velocity versus time, and acceleration versus time. So this is from those pictures of graphs that I actually gave you in the study guide. And since they're moving forwards, that's why they have the shape that they have. All right, so that's the first free response question. In the last video, I will do the second free response question.